Hello, this is Group Melmetal. Our subject is climate change related natural disasters. First, I want to explain our motivation. Climate change, which is one of the biggest problems humanity faced this century, is one of the most significant factors that will shape most of our lives. Hence, understanding the effects it will have on our futures is our primary motivation. Aside from us, climate change will reduce biodiversity, eliminate species, and that's why we wanted to underline these issues as well. Raising people's awareness about climate change, which we explained the importance of, is also one of our motivations.
In this part, we made an interactive visualization of the five coldest top countries by the year to examine the relationship between temperature change and climate change. Then we aim to show the areas that change most over the year's temperature changes. Finally, we can see the temperature distribution dynamics and seasonal change of all countries one by one, and also temperature distribution dynamics, average temperature dynamics on the country level of each countries. For example, we can select the other countries in that part, and we can examine the all data.
In order to evaluate the relationship between climate change and natural disaster through the main reasons of climate change, such as greenhouse gas emissions, we prefer to use visualization methods to investigate the effect of it, with a point chart that shows greenhouse gas emissions globally by sectors. Also, with 2-3 maps that for visualization amount of carbon dioxide emission that each country causes. In one of them, it's compared with total global amount, and in the other one, it's compared in just between countries. Also, another visualization, which is a pie chart that is used to show the total amount of carbon dioxide emission in the form of increasing rates globally by the year. Another visualization we use to show the temperature change globally is the global chart that shows temperature changes with the population of countries, assuming the chart with interactive modes.
In this part, we examined how much each country got affected by floods and visualize it. In order to calculate how bad a country affected, we need a metric. So we use how many people a flood killed and how many people it replaced and combined them. We deleted some countries got in our data set because the library we used to visualize didn't support those country names. We also changed some country names to be able to fit the library pygol, such as Burma, Myanmar. And to show how bad countries got affected, we grouped into 5 groups named slightly affected, moderately affected, badly affected, heavily affected, and severely affected. We visualized Asian countries such as China and India was severely affected. So we choose India to build our flood model.
To build our flood model, we used the Kerala flood dataset. To understand the data we visualized, the amount of rainfall for each month, which can be seen right here. To build our model, we used K-neighbors classifier, logistic regression, decision tree, and random forest classifier methods. During this, we also listed the correlation values of each month using logistic regression, which are these values. Then we listed the accuracy values of each model, sorted them, and choose the model with the highest accuracy, which is logistic regression, which can be seen right here. And lastly, we tried to investigate a correlation between how much a country polluted and how bad that country got affected by the climate change. To do that, we group the countries by their emissions and populations, which is affected by flood. And then we clustered the data, and we couldn't find a strong correlation between these two factors. Our clusters is this. We have 4 groups because we used the album method to find number of clusters, and it gave us the result of 4.
Firstly, we start out by loading up the Twitter sentiment data. First up, we have a strong aversion to keeping track of numeric case, so we replace all the numeric values with the appropriate labels given by the dataset. We will be vectorizing our text data before passing it throughout our model. We need to vectorize our data for similar reasons to why we have ASCII and Unicode. Machines don't understand letters and words. Then we looked out by some models. For example, we use Navia bias theorem, and we have some observations. For example, any improvement of random first, but it still performs pretty poorly. Also, it still classifies the motives with the poor sentiment. Precision, accuracy, and effort scores so have significantly improved across the other sentiment. And while Navia bias performs better, its performance is likely hampered by the balance of the data we have. And also we have some other models, nearest neighbors algorithm, and like logistic regression, and etc.
By making use of the daily temperature values, amount of change to the general data of 2019, we developed the forecast with the random tree algorithm, which predicts the climate change will occur with 94% accuracy.